welcome screen has returned. I finally, wasn't lazy this morning and actually did it. So I hope that you feel especially welcome today. So
Thank you. From the bottom of our hearts.
I'm glad you guys appreciate it. All right, as far as today is concerned, you are going to need a long list of materials. So let's start at the top. First, you need something to write with. Second, hold on a second. Let me explain it all, and then you guys can go get it. All right, so first, something to write with. Second, you need your own copy of the periodic table. Third, you need 2 sheets. One I gave to you yesterday. It says the modern periodic table on the top of it. The other one was on the blue tray by the door if you didn't pick it up on the way in. Then, you may need your orbital filling diagram from the last unit, because we're going to talk about a little bit of that at the beginning. And the last thing you need is you're going to need some things to color with, because we're going to do a little bit of coloring today. If you don't have colored pencils or markers with you, back on the back table in the corner, there is a, hold on. There is a box of colored pencils. There is not enough for all of you to grab like 5, and that's how many colors you're going to need. So, between you and the person next to you, or a couple people around you, maybe you guys get a group of 5 or 6, and you can just trade them around. You don't all have to necessarily color coordinate on your sheets. Okay? Ready? Let's see if we can do this in 2 minutes. Go. City and Washington, D.C., and then just sort of like come right across. They like said, make sure you have some water and some extra food in case the power goes out. Like,
Wait, we live in Cleveland.
yeah, we live in Cleveland. We don't have hurricanes. All right. Even though we were just talking about Hurricane Sandy, I have faith that we're going to have school the next couple of days. So I updated updated the calendar for you so that you can see a couple of things. I haven't updated the calendar in a couple of days, but I updated it now. So, first, I mean, if the power goes out, then, you know, we can't have school if there's no power here.
How'd the power go out?
Not here. So,
I'd be okay with that.
what?
The power going out.
Yeah, I mean,
I'd be okay with that.
all right. As far as the calendar goes, on Tuesday of this week, we did Mendeleev and periodic law, and we started talking about how Mendeleev put his periodic table together, what are some of the things that he started seeing. Then, yesterday, actually Wednesday for you guys, we did the Alkaline Earth Metals Lab. If you have not turned in the Alkaline Earth Metals Lab, please notice that today it says Alkaline Earth Metals Lab due. I think a lot of you got the questions done, but if you didn't get the questions done, please finish that up sometime in the near future and get that over in the tray over on the side. Yes, Gabe?
Jeremy, why do you ever check the homework?
Say again?
Why do you ever check the homework?
I do check the homework when I give you your homework quiz in class, remember?
What?
You know that quiz that I give you, like it's an open note quiz and you're allowed to use your homework? That's me checking up on whether you're doing your homework or not. Now, if it's something like this, a chapter like this, it's only like a week and a half long, and it's not really much time for me to do that, okay? Gabe, do you want me to check your homework like every day?
No.
No, you don't want me to do that.
I really want
So, Gabe, what would happen is if I did check your homework every day, no, you guys would all just start copying the two people that do their homework. And I don't need to spend time marking things that you copy. If you want to do it, it's there for you. It'll help you, I promise. If you do your homework, you'll do better, okay? But that's where the quiz comes in as far as me checking up on, are you understanding the concepts that we're doing and stuff like that. Some of you probably should be doing the homework on a more regular basis, considering the grades that you're getting, so that you can practice a little bit better and, you know, get some of those things done. Not so saying you give, I'm just saying in general. Okay? But that's why. Okay? There's like some reading assignments and stuff, you know, things that we do in class that might be helpful for you to read up on beforehand, and so it's there for you. All right, today, after the lab on Wednesday, we started getting into a little bit about the periodic table and some definition and some terms. We'll continue that today. After we finish that up, we will start talking about some specific families on the periodic table and talk about the names of some of those families, some of the properties, the elements that are in those families, and we'll get to that later today. Then, if we jump ahead to next week, right now, on Monday of next week, the web quest that you did on Friday and Monday when I wasn't here, I'd like you to bring that with you on Monday. I'm going to check and see if you did it. That's all. I'll give you points for doing it. It's just a completion grade. Okay? Yes, Dave?
The noble gases and halogens,
Yes.
are they considered a non-metal? or metal?
Absolutely. We will talk about those a little bit more today. Definitely non-metal. Okay? Trisha, go ahead.
So, in my lab class,
Yeah.
like, I did most of it as well, but I went to the word kind of analysis. Don't print for some reason. I don't know if it's like easy or something like that. But could I just like take a picture of it on my phone and show it to you?
Yeah, it's
if
fine.
it's just easier?
Or see, maybe can you see if you can like send it back here and try and print it here maybe or something like that? Like,
Can I email it?
yeah, email. Maybe try and email it to yourself and see maybe if you can print it off in the library or something like that.
Yeah, because I tried copying and pasting it in different things. Like I tried emailing it like to a different computer in my house, but like it like the chart just like went like it like flipped and like
Okay.
got jumbled.
I tried to save it as a text format instead of like a Word doc. So hopefully you wouldn't have that problem, but see maybe if you can do it, and if you can't, Trisha, then you can just email it to me and that'll be fine. So
And then is the lab that we did, is that like are you grading each question or is it just like if you did it?
the lab that we did, I will grade like some questions on it. I might not grade every question, but I will grade some questions. That'll be more of a hey, did you answer the questions properly, stuff like that. All right, then right now, tests scheduled for Tuesday of next week. So Tuesday, October 30th. This morning, if you go back to the homepage sheets. I added Unit 4, periodic table and periodic law. So the objective sheet is up there, so you can start taking a look at that, preparing yourself for tests scheduled for next Tuesday. Okay? It's going to be a short test. It hasn't been that long of a unit, right? We haven't done that much stuff. But it will be your first test for this grading period. Yes, Mina?
Do you have a quiz this?
No quiz this one because the unit is so short that I figured they just wouldn't give you a quiz here, and you know. All right, good there. All right. On Wednesday. On Wednesday, we started talking a little bit about our current version of the periodic table, how it's similar, how it's different from Mendeleev. So first, does it still show us trends and properties and grouping of atoms or grouping of elements like Mendeleev's periodic table did?
Yes.
It does. But is it arranged exactly the same as Mendeleev's periodic table? It is not, right? Our periodic table is first organized by increasing atomic number, whereas Mendeleev's periodic table was increasing atomic mass, right? But we realized after a while that some of those things that seemed weird on Mendeleev's periodic table were resolved if we reordered them in terms of increasing atomic number. Okay? The hooligans in this class.
I didn't know that. I don't know how he did this without me.
So you didn't even see him doing it?
No.
Wow. That makes it even better. All right. Information that we can find in the periodic table, right? There it is. Name, symbol, atomic number, average atomic mass. All right. Vocab. Each row on the periodic table. We said each row we refer to as a period. All right. Apparently doesn't want to highlight. Oh, there it is. Okay. But then each column can go by one of two names, either a group or a family. It really doesn't matter what you call them, they are equivalent. As far as identifying and distinguishing those rows and columns, right, we have a numbering system. The rows, the periods, are numbered just by increasing principal quantum number, and we'll see that a little bit as we go along more today. Then columns, we just start on the left-hand side, start at 1, order them numerically across to 18. Good there? Okay. At the end of class on Tuesday, I had you draw a couple of things for me. I'm going to have you draw a couple of other things for me. Okay. Today, ultimately, I need electron configurations. So if you can do that right off the bat without drawing an orbital diagram first, that's fine. But if you can, if you have to draw the orbital diagram first, that's okay. It's just going to slow you down. Okay? So I would like you to write electron configurations for 6 elements. Okay? I would like you to, you're not turning this in, it's just, somewhere, on the side of your paper, on a separate sheet, something like that, just so we can look back and compare them. Okay? I would like you to write electron configurations for lithium, sodium, and potassium. Then I would also like you to write electron configurations for fluorine, chlorine, and bromine. If you would like to work together with the person next to you to sort of work these out, feel free to do so. Okay? Let's see if we can do a couple of minutes and get back so we can start using this information. Go. So electron configurations for those 6 elements. Yep.
Wait, so like that?
Yep. Yeah, we said that the electron configuration is a shorthand way of representing the orbital diagram, right? It's good for finding patterns, and that's really what we want to do. 6 electron configurations up on the board. Okay. I hope that none of them were too difficult until you got to bromine. Bromine's a little bit tricky, right? If you follow your orbital filling chart, you'll see that after we go 1s, 2s, 2p, 3s, 3p, but then after 3p, there is a 4s level, right? And then after your 4s level, there is your 3d level. After 3d, then comes 4p. That's just going right up from the bottom to the top in your orbital filling chart. Okay? Is that good? Yes. I should pull this up. Clear. Joe? I should have pulled that up earlier. But I didn't. So there's the chart, right? And let's scoot this up just a little bit here. Alright. So we said we just kind of start at the bottom and work our way up, right? So there's 1s, 2s, 2p, right? 3p orbitals, right? That's what the 3 lines represent. 3s, 3p, 3p orbitals again, because that's what the 3 lines represent. Then the next one we come across is 4s. The next one up from that is the 3d level, 5d orbitals. That's why there's 5 lines there. That means each orbital we said can hold how many electrons? 2. So that means that there's 10 electrons in that 3d level. Once all 5 of those are full, then we move up, and the next level we come across is 4p. Again, we see that the 3p orbitals, even though it's the 4th energy level, go there. Is that good? Okay. All right. But more importantly, Gabe, go ahead.
I was just wondering, is there anything higher than like a 6F on the levels?
Technically, yes. Like the spaces exist, but we don't have atoms that have enough electrons to fill those spaces. Does that make sense? Okay. So those, like, on this chart here, right? Not this chart. This chart. Nope. These are all just spaces around the nucleus, right? Hydrogen has all of these spaces, but it doesn't have enough electrons to fill up all the spaces. Does that make sense? So really, these are just labeling of spaces. In theory, it could go to the 8th level, 9th level, 10th level, right? But there's not enough no atoms have enough electrons to fill those on like a regular sort of basis, okay? Nate, go ahead.
Is there like a cap? Because like wouldn't just take up like a lot of space.
Yeah, I mean, now you're starting talking about a big, big atom because there's lots of spaces. But like I said, if you look, you know, the highest atomic number that's over there is 110, 111-ish, somewhere around there, 115, whatever, okay? But that's also the top number of electrons that an atom will have as well, right? So it's just a matter of not filling up those, like, the spaces might be there, it's just not filled up. It's like an apartment building that has lots of apartments, but not enough people to live in those apartments. Does that make sense?
Yeah.
Okay. All right. But more importantly, we kind of looked at this yesterday, right? If we look at these 3 elements, right? First, if you find them on the periodic table, where do all 3 of them show up on the periodic table? They're all in the same family, right? Specifically that first family, okay? And because of that, or more likely, this leads to that, right? If we look at their electron configurations, we see similarities in those electron configurations at the end, okay? Same thing with these 3 elements, right? For bromine, even though there's a 3D level thrown in between there, right? We see that there is an S and a P pattern that is developing in these atoms in the highest energy level. Does that make sense? Okay? That pattern gets summarized like this. This isn't on your outline, but if we look at elements in the same family, we will see that their electron configurations are similar, but differ based on what row they're in, right? Elements in group 1 end in NS1, right? Those are the lithium, the sodium, and the potassium that I just had to draw. What does the N represent when it says NS1? Yeah? Which number? Maybe go ahead.
The principal.
The principal quantum number, or the highest energy level. Now, more practically, where does that number represent as far as its location on the periodic table? From a more practical standpoint, where do we get that number from? So, here's the formula for potassium. It ends in 4s1. If you look on the periodic table, right? This probably isn't going to look very good later on when people watch this. It's in the 4th row. That's what I wanted you to get, right? So if it's in the 4th row, right? There's potassium. It's in the 4th row. If it's in the 4th row, what's N going to be for potassium? 4. Okay? So even though you may have never heard of francium in your life, element number 87, can you tell me what its electron configuration is going to look like at the end? Yeah, what's it going to look like? 7s1. Because it's in the 7th row, it's in that column, its electron configuration matches. Okay? So, here, iodine, right? Iodine, element number 53. What row is it in? It's in the 5th row. It's in group 17. So its ending electron configuration is going to be 5s2, 5p5. Does that make sense? That's the similarity in pattern that we see. Now, where did we say that all led to? Repeatable patterns of properties are the results of similar electron configurations in all elements in the same family. And then this repeatable pattern we've already termed periodic law. Okay? So that should take you through the very bottom of the first page of that outline, and then the top of the back page, the outline from the other day. So this repeatable pattern of properties is the result of a similar electron arrangement in all the elements in the same family. And we refer to this repeatable pattern as periodic law, which we've already discussed a couple times. Other outline when we started the other day. So as far as that outline goes, right? Just to make sure you got it all filled in properly. Once again, if I was good, I'd have this up already, but so down at the bottom of this outline here, right? Elements in the same group have what? Similar chemical properties. Those chemical properties repeat in a predictable pattern when elements are arranged by increasing atomic number or atomic number. Then on the back side, this repeatable pattern of properties is a result of similar electron arrangements or similar electron configurations in all elements of the same family. Good there? Okay. that we see on the periodic table. There are basically 4 big classification of elements that we show up on the periodic table. First is metals. Second is nonmetals. Third, transition metals. And fourth, metalloids. Transition metals, there's another subgrouping that we call the inner transition metals. But, more importantly, like it says underneath that grouping of those 4 things, right? Letter E on your outline. If we have elements that are in the same group, what should we be seeing about them? If we group them together in a same group, Gabe, what should we see about them?
It shows similar characteristics.
They should have similar characteristics, right? The more similar they are, the better the grouping is. We'll see that, these groups are big, broad categories, but there are other groups that we slim it down a little bit more and make them a little more specific. Good there? Okay. First, I want to start off on your outline. Okay. You'll notice that on the back there is a big blank periodic table. So let's make sure that we can identify these big regions on the periodic table. I'm going to start with the metalloids because metalloids is a good transition. If we have metals, nonmetals, and metalloids, what do you think metalloids are going to be like?
Metal.
They're going to be metal-ish, but they're also going to be non-metal-ish, right? They're a nice transition between metals and non-metals. Okay? If you look on your periodic table, the metalloids are kind of like a lightish green color. Okay? They start up here in the top of this little section with boron. That's our first metalloid. Okay? And then kind of runs like this, and then like this. What do we have there? And then like this. Right?
No, there.
Wait, what do we write?
Did I do it too much?
Either
I'm
shape.
going off of there. Yeah, how you show this, I really don't care, right? On your periodic table, right? These are where your colors are going to come in, right? So you can X them out if you would like. If you want to color them in, that's fine too. Totally up to you, okay? But in my periodic table, which I apparently can't choose, there, right? So green, I have labeled as my metalloids. Okay? Yeah, if you want to color them in, feel free to do so. I'm just going to do X's because I'm not going to color the whole time.
Wait, can you use the color?
Yeah. Joe, the green ones that I've labeled up here are my metalloids. Okay. All right. To the right of your metalloids. To the right of the metalloids. So, here. Also this one up on the top, and then way over here in the top left. Those are going to be your non-metals. Non-metals. So the ones that I have X'd with red are going to be the non-metals. Once you start looking at properties of non-metals, you'll find that non-metals are kind of like the breakfast food category that we were discussing the other day. There is a lot of variation within the group that we label as non-metals. The thing that makes them all similar is the fact that they are not metals. Okay? Some of the elements that are in the non-metal category are gases. Some are liquids. Some are solids. Some are very, very, very reactive, and they form lots of compounds with other elements. Some don't form any compounds at all. So there is a lot of variation within this category that we label as non-metals. Okay? Emma, go ahead.
The metalloids that you marked on the board, are
They're a little bit different than ones on your periodic table, okay? So go with the ones I have up on the board. Although, Emma, we'll see that that line, especially with the line of demarcation between when we get a little bit closer down there at the bottom, really is kind of fuzzy as far as what's a metal, what's a metalloid at that point in time, okay? What? They are radioactive too, as well. Some of those ones down at the bottom are. Go with what I have up on the board, okay? Although, like at that point, yeah, it's kind of fuzzy as far as where the division line is. All right, so that leaves us with a bunch of other stuff, right? Yep. We'll find that the variation in this category, everything that I haven't marked yet is going to be a metal. But there are certain sections that we label a little bit differently. Specifically, this section right through here. This quote-unquote short part of the periodic table. These are called the transition metals, or sometimes you'll see them called the transition elements. Same thing, just a different way of showing them. Okay? So that whole short part of the periodic table. These are the transition metals, or the transition elements. And then, these two rows down at the bottom we usually refer to as the inner transition metals, or the inner transition elements. So those two rows that sort of sit off on the bottom. The inner transition metals, or the inner transition elements. Up to you, Minka. If I shade a question or a section on the periodic table on the test and say which section is this, you got to know which section it is. How you do that, I don't really care. And then the ones that we haven't colored in yet, except like these ones down here in the bottom right-hand corner. Okay. Those ones kind of exist, but not exactly. Okay. So don't worry so much about like these bottom three right here. Okay, hey, go ahead.
Are those ones, is that kind of like how that one guy predicted that there were going to be elements there?
Yeah, kind of. Although what we find out is that these ones that exist here are very, very unstable. Like they don't exist in nature. We can sort of make them in a laboratory, but they will fall apart. They're very radioactive, okay, because the nucleus is so unstable. Okay. But the rest of those, so I'll use orange. The ones that I'm Xing in orange, these are your metals. Now, keep in mind, transition metals are metals. So all transition metals are metals, but not all metals are transition metals. There are similarities between the ones that we label metals and the ones that we label transition metals, but obviously there's a little bit of difference, or else we wouldn't call them that. We would call them something different. These ones that have yellow dots, they're pretty unstable and don't exist in nature anyway, so we kind of don't worry about them too much. Yes, Gabe, go ahead.
When they don't exist in nature,
Mhm.
then why are they on the periodic table?
Because technically, just because something doesn't exist in nature doesn't mean that we can't make it happen in a laboratory or something like that. Okay? But what we find out is that those elements are very, very unstable, and they'll basically decompose as soon as we put them together. So they're not real useful to us from that standpoint, you know? Alright, are we good with these big regions of the periodic table? Questions?
I need a label.
As far as a pattern goes, because that's what we look for, right? Where are the metals found on our periodic table? Generally, what side? On the left side. The farther left you go on the periodic table, the more metallic these elements are. The farther right you go, the less metallic they are. So these elements over here in the first column, these elements over here on the first column, right? These are our most metallic elements, whereas these ones over here are least metallic elements. And we can summarize that up. Right? Across a period from left to right, elements become less metallic and more non-metallic. Metal elements on the left, non-metallic elements on the right.
What about the each elements?
So we said that if we're going to group them together, Joe, what should we see about those elements? If we're going to put them in a category together, what would we like to see? And, yeah, we would like to see things that have similar properties together, right? That's generally where we go with that. All right, questions? So like I told you earlier, objective sheet is posted. Because we didn't get to any of that outline today, the new outline that I gave you, I'm thinking we might have to put test off maybe until the beginning of block day next week. It only makes sense, and, go there. But objective sheet is posted. Again, there is also some homework for tonight, so if you want to take a look at that, you can. All right. Homework for tonight, a couple of questions from the book relating to families that that show up on the periodic table. Okay? I will see you guys on Monday. Have a good weekend.
Yeah, done.